Oh. This is the type of question that a student say, hey, I don't like math no more. I hate math. See, this is the reason why they say, hey, look, the moment I saw that question, I started to hate math. But hey, it's just because you didn't have somebody to show you how to solve this stuff. This stuff is easy, man. Very easy. Now, let's get started. Without further ado, my name is Mntwana. Mntwana, okay? The original black man and African man. I'm a caveman. Now let's get started. So we have a question right here. This is solved. So I'm trying to save a lot of time with a fast pace so we can get down with this question, right? It's easy. Now, I can start with the face question. So what I'm gonna do, this one face. I'm gonna do face. When there's a root, this is how you do. Make sure you split this, right? Make sure you split that. So I'm gonna say you got integral. Now this is gonna be 1 over. If I complete the square right there, this is gonna be x plus 11. Let's change. We can leave like that. No problem. 11. Okay, so when you complete the square, let's say x squared plus 11x plus 5. So I can separate. Mean the 5 is gonna be here. Take 11 divided by 2 squares is gonna be plus 121 over 4. It's going to be minus 121 over 4. So then this is going to be x plus 11 over 2 bracket square. And this I can put over 1 and then common divisor is going to be 20 minus 121 over 4. And this is going to be negative 101 over 4. So then we're going to have over 11 over 2. Oh, this pen is finished. I'm sorry. 11 over 2 bracket square. And then we minus 101 over 4. But remember, you want to put this as a root. So if you want to put this as a root, means I can simply say 101 bracket and then this over 2 and then square, which means the same thing because on the square it's going to be 101 and then it's going to be 4. So I can simply say, because I want to put all this in a square, but this must have a root. So it does not make any difference, and this will make it 2. Because look, 101 root only for 101. Square is only 101, and then 2 square equal to 4, which is the same as that. And you have minus outside. So what we're going to do, we're going to say, well, let me try to do it fast way. So now we're going to say, well, so if I reach to this point here, right, there's a minus here. So since there's a minus right here, what I'm going to do is difference of 2 square. And since this 2 is a different 2 square, means I can say, well, let me let this equal to any certain number. Let's say equal to u or k, whatever. Okay, so say let k or u equal to x plus 11 over 2. So dk equal to dx. So I can say integral, excuse me, and this dx, remember. Dx equal to dk. So this is going to be dk. And then I have my root. All this is going to be k squared. Because let's go to k minus. This is going to be the same thing here. 101 square root, and this is going to be 2. 101. And then all bracket on square. So what I'm going to do now, I'm going to do what? Different 2 square. So this time is a different 2 square. This is going to be integral dk. And this is going to be k minus, because if somebody give you a minus b, means like I still have my root. And the k minus 101 over 2. K plus 101 over 2 bracket dk. So what I'm going to do for this integral here, I must do partial fractional integral. Do partial fraction, work it out so I can get a and b. So this time we say integral a over the first one, which is k, 101 over 2 plus b, okay, 101 square root over 2 close bracket dk. So what I'm going to do, I have to work it out that one and come back and replace that. So let's solve the partial fraction then. Excuse me, sorry, my mouse is kind of dry. So what I'm going to do, my apologies, sorry, I've got some cracks in my mouth. I apologize. Like my mouth get dry, so I have to apply lip S, like oilish a little bit, because sometimes it get cracked. Okay. So what I want to do here, I have to get the value of b so I can apply ln and apply and solve that integral. So what I'll do is, okay, well, Oh, do I need this? Okay, I'll have to come back in. So what I'm going to do is the space is not enough here, but hey, I can handle this. So I'll say, let me simply leave the integral. Leave the integral. So we say a over k minus, let's go to this one, 2 but plus, wait. Write this, which is going to be 1 over, means this is 1 over everything, so it's going to be 1. Oh, wait, I'm wrong. I'm very, very wrong. You know why I'm very wrong? Because there's a root here. See? There's a root, and look, there's a root here. See? Since there's a root means I do it wrong. I'm not supposed to do this. There is a root, you don't have to do this. This method I could have done when there's no root means for the second one. So what's supposed to be done here, right here, was more than enough for me. See, if there was no root, I would say yes. So since there's a root, I'll say, well, this was more than enough for me right here, because there's a root. But if there's no root, you see, so I want to show you that, I also make mistakes sometimes. So mistake comes if you not look careful, stuff like that. So since there's a root, which is this one here, look how I'm going to do. I'll say, we have a rule which say if you have an integral, let's say 1, which is dx, and then you have a f of x square plus or minus a square dx. Okay, since there's a root, so this let me say 1 ln bracket 1 over a, and then you put your absolute. So 1 over ln 1 over a, and then write exactly fx, okay, and then you plus all f of x, and then you plus c, and then you close the bracket. That's how you do it. So this is similar to that. It's very similar. You can see it's very similar. So we're going to say this is going to become, okay, this is equal to that one. Ln bracket 1 over a. What is a? A is 101 over 2. But this 2 is going to go to the top, so it's going to be 2 over. And then absolute. This is this. But remember, this came from that. So I can simply, this is, which question was that? Was this one, because there's a root. So I can write this or I can write that, but I'd rather write this original one. Exactly. So it's going to be x squared plus 11, x plus 5. And then after that, you say you plus, what you plussing? F of x. What is f of x? F of x only this, because it's f of x plus that. F of x minus, so write only this one. X plus 11 over 2. Then you close your bracket, then plus c. And that's the end of the question. See? So you see how I made a mistake? So I also make mistakes sometimes. I did this question just to show you that how I make mistakes. So we're done with that question. Now we want to go for question number 3. I'll go, this is need a lot of space. So we go question number 3. Question number 3. It's a minute. And my whiteboard is very dead. Sorry, thank you for your patience, I appreciate it. Okay, cool. So question number 1 we're done already. Now we go to question number 2, number 3. Number 3, this is easy. Because you know what you're going to do? There's no root. So if there's no root, it's way easy. So what you need to do, you need to test the root of the quadratic equation. How? The root of quadratic equation, you test us by b squared minus 4ac. If this value is greater than 0, then you can factorize. But if this value is less than 0, then you cannot factorize. You can, but by complex factorization. You don't need that because this is not complex integration. So you don't need that. So if it's less than 0, then do not factorize. You just know, okay, I can factorize here. What I need to do completing the square. So I'm going to say, well, let me test if it's greater than 0, less than 0. So what is b? B is 4 squared to 16 minus 4 times a equal to 1 times c equal to 20. So this is going to be 80, 16 minus 80 equal to 64. See? So yes, this is greater than 0. So for that case, yes, you can factorize because it's greater than 0. So means you can factorize. I don't have to do completing the square. You can complete the square if you want. You know what I'm saying? You can do it. I think it can be the best. So say, okay, this is going to be integral. So this is going to be 1 over. Because if I want to do like factorize, I can do, but then I have to apply ln and partial fraction. But I don't want to go through the partial fraction rule. Let me do tan, because sometimes they can say use partial fraction. They can recommend the same question. So I'm going to do by partial fraction the same question that I'm going to do by. So not all of them you can do by tan inverse. Some you can, but let's do for both. So now this is going to be x. If you do completing the square, it's going to be x plus 2 square. And this is going to be plus 20, and this is going to be 20 minus 4 divided by 2 equal to 2 square equal to 4, which is going to be equal to 4 equal to 16. 16 means 4 square. I believe you know how to do completing the square, right? So, yes. So what we're going to do here, this is tan inverse. Because tan inverse of trig, say, if you have an integral 1 f of x square plus a square, please let me say 1 over a at tan. When you say at tan, means tan inverse. Tan inverse of a function over a, and then with plus c. And you can see the same format because function square is a function square plus number square. There is no root, it's just a line, So now we can do, okay, 1 over a. What is a? A is a 4 with no square. Add tan, when you say add tan and tan inverse, the same thing. And then write this one x plus 2 over this number here with nothing. And then plus c. So, but the same question, if I had to factorize this question, no, I don't think I'll go for. I can do that. I can do it if I factorize. But I hear which number? 4 and 5. Yeah, 4 and 5. 5 and 5, yeah, it's going to give you 20. 4 and 5. No. Which number I'm going to factorize here? Which is going to be so lame. I would rather go for this one. You understand what I'm saying? But hey, if you want to try, use a partial fraction, you can, but I don't go for that for this case. So we're done with that one. Now we go to question number 4. Let's go to question number 4. Number 4, 5, and then I'll do the last one, which is question number 2. Because question number 2 needs a lot of space. Okay, so question number 4 is easy. So it's almost similar to that, but it has a root. So we say whenever you have a root, they're tricky the same. So this is going to be integral. So we know 1 over. So this one we did already completing the square. We say this is a root. So this is going to be x plus 2 if you complete the square, and this is going to be plus what? Plus 16. 16 is 4 squared. Complete the square. I do believe you know how to complete the square, right? 4th grade, grade 10, grade 9, grade 8. Okay, so we have that. So since you have a root, we say if you have a root integral 1, and there you have it, f of x square plus or minus whatever you have, means f x plus a square. This same is saying 1 or no ln 1 over a. We know a, this number, and then you say we say absolute. You write exactly f of x plus a square with the root, and then you plus with no root, it's just f of x. And then you close your absolute plus constant. So we're going to do the same thing here. Means it's going to be, which question there? This one here. So it's going to be 1 over a. What is a? A equal to 4. And they say ln face bracket 1 over a equal to 4. You follow this one, right? Now you say this is going to be, then after you say absolute. You see what I'm saying? Absolute. Okay, absolute. And then we write exactly, which is this one. But remember this is this. So either I can write this or that, but I'll rather write it. Either you write this or that, because the same thing, because this one came from that. So I can say x squared plus 4x plus 20, and we plus only this x plus 2 with no square, and then plus c. So we're done with question number 4. Now we go to question number 5, and then 6, and then number 2 is going to be the last one. Okay, let's go. Okay, question number 5. So what I want to do, I'll change it. But a tricky double angle say, look, for double angle tricky say, if you have a cos, double your angle equal to cos square x minus sine square x. But look, we want to get sine square. So let me change everything to sine. It's going to be, what is cos square? Cos square is 1 minus sine. It's going to be 1 minus 2 of the sine, because 1 minus sine, 1 minus square, sine, this could be cos double angle. So look, since you want to get sine square angle, but this is 2. If this is going to be 2, means this is going to be 4 then. And if I want to get this, means I'll take to the right, it's going to be 2 sine square 2 theta equal to 1 minus, this is going to go over cos 4x. Divided by 2 means it's going to be over 2, and this is going to cancel. So if I replace this, I'll replace with that. So it's going to be integral, replace that, it's going to be 1 minus cos 4x over 2. So I can take 1 over 2 out at the back. So I'm saying, and then we're going to go dx. So what we do, we can separate the integral, and this is going to be 1 over 2. Look, integral for 1 dx equal to x minus integral of cos, that is going to be 1 over 4 sine 4x. Okay, plus constant. Do you understand what I'm saying? Then we plus constant, then we're done. Oh, how did you get this? Look, if somebody give you integral sine or cos, it does not matter, right? The sign is cos f a function dx. This meaning you say 1 over derivative of this function, and then you say, okay, when you derivative cos, you get sine. That's how you do it, you plus constant, because there's no limit. You see what I'm saying? That's why when I integrate cos of 4x, look, integrate cos of 4x, meaning, okay, derivative 4x, you get 4, means you say 1 over that number that you derivate, which is 4, like here, 1 over derivative function. So 1 over 4, and then you say, when you derivate cos of 4x, sine, it's going to give sine of 4x plus. So I'm saying, that's to say here, but remember here, you must multiply in, this will be a half x, and multiply in is going to be 1 minus 1 over 80 sine of 4x plus constant, because you don't have no limit. Now we go to question number 6. Question number 6. Question number 6. Oh, my whiteboard is very late. Okay, anyway, no problem. Question number 6 is almost the same tactic, right? This is tricky, but we must change this, right? Because it's going to be a problem for you if you have a power of the tricky. So go to double angle. Double angle say if you have a cos, double your angle, let's say theta or x for now, equal to cos. But now everything is cos, means cos of square of your angle minus sine square of your angle. But now you want to get everything cos. Means I'll say, okay, means this sine must go. What is sine? Sine meaning 1 minus sine square x. So negative times could be negative 1. This and this could be 2. Oh, sorry, I'm doing something silly. This you want to eliminate what? Sine. Sine means 1 minus cos square x. Means I have to eliminate this. So this is going to become, okay, well, look, minus. What is sine? 1 minus cos square x. And this is going to be cos square x. Look, multiply. It's going to be equal to negative plus. It's going to be 2 cos minus 1 cos double angle. But look, you don't just want, because me, I can just plug it straight away. I know all of them in my head, but I'm just showing you so you can know the tricks. But look here, I just need cos of 5x square. I mean, this must be what? Must be 5x squared. This is 5, this must be twice of that, which is going to be 10. But I need these to make something, so I can come and replace these. So it means 1 come over is going to be cos of 10x plus 1 over this 2 equal to cos of 5x squared. So if I had to replace that one, I say this is integral. 1 over 2 is going to go at the back, because this 1 over 2 goes to the back, and then we say, okay, well, replace that one. This equal to that, cos of 10x plus 1 bracket d dx. Now, 1 over 2, when you integrate cos 10x, like I showed you, is going to be 1 over derivative of 10x, which equal 10 right at the bottom. And when you derivate cos, you're going to get sine, but what? 10x, and then with plus. When you integrate 1, you're going to get x, but what? Yeah, plus constant. Multiply that out. This is going to be 1 over 20, and then sine 10x plus multiply 0.5 or half x plus c, and then we're done. For that case, listen, man, thanks a lot for your time. And that's what I told you. Now I understand a lot of students, they find it very, very challenging because you see me also, I almost make a silly mistake because of the eyes. So if you don't look your eyes careful, if you not pay attention on, oh, I didn't look careful, then you end up making mistake for something which you shouldn't. Thanks a lot for your time, man. For that being said, my name is Mntwana. Okay? Easy. Follow me on my social media, Mntwana _ on Instagram, Mntwana _ Wabantu, on Facebook the same name, Mntwana Wabantu. If you have any query, you want us to talk some serious issues, you want to contact me, you want to reach me, you can direct me message. Feel free anytime. With that being said, peace and love, and I'll see you soon. Peace.